In the vastness of space, where the infinite mysteries of the universe are seeking to be discovered, a celestial body has long captured the imagination of man, Mars. For centuries, the red planet has been the subject of many theories, speculations and dreams. Is Mars a slow planet full of life? Is it still hiding secrets under its red face? Recent discoveries have raised these questions with a passion that cannot be ignored. As our scientific instruments delve deeper into the Martian landscape, discoveries are made that challenge everything we thought we knew. In these revelations there is a profound knowledge that can change our understanding of life in the world. Today we begin our journey to explore these groundbreaking discoveries and explore the road ahead. Will Mars reveal his secrets, or will he continue to protect them? Join us as we delve into the mysteries of the red planet and uncover important clues to life beyond Earth. Imagine a world where new discoveries are pushing the boundaries of what is known. Mars, our nearest planet, symbolizes mystery and wonder. Recent discoveries, especially those made by the Curiosity rover, have shaken the scientific community and brought us closer to answering the age-old question, are we alone in the universe? Mars visions are not just a series of events. It's a piece of the puzzle that can reveal a much more complex and interesting picture than we ever imagined. Could these findings be the key to uncovering the mysteries of life on Mars? The answer is closer than we think. Curiosity's journey to Mars began on August 6, 2012, when it successfully landed on the red planet's surface. Since then, this small but powerful piece of technology has traveled about 15 miles on Mars and performed a variety of scientific experiments. The mission is to explore the geology of Mars, taking high-resolution images and analyzing rock samples to uncover the planet's past. One of Curiosity's main missions is to investigate the potential for life on Mars by examining the surface and subsurface for signs of water and organic compounds. Recently, Curiosity has discovered something that has attracted the attention of scientists around the world. Curiosity discovered something unexpected while examining muddy sedimentary rocks in an ancient lake at Gale Crater. Gale Crater is thought to have formed about 3.6 billion years ago when an asteroid hit the surface of Mars. The impact created water that has long since dried up, leaving behind sedimentary rocks containing minerals such as clay. These clay deposits are important because mud is formed when rock minerals break down in the presence of water and can be a sign of past life. Curiosity collected 2 lichen samples from this ancient lake, about 3.5 billion years old and only 1,200 feet apart. However, upon closer examination, researchers noticed something strange. One sample contains too few clay minerals and too high a concentration of iron oxide, the compound responsible for Mars' red color. The discovery raised the questions: what could have caused this unexpected combination? Scientists believe the answer lies in the chemistry of the world's oldest water. Scientists say that the mud layers were embedded in salt water or brine. This salt water changed the mineral composition of the clay, darkening and destroying some of the original soil layers. This process, known as diagenesis, erases evidence of past life on Mars. But it also created new chemical processes to support life. The discovery of these salt deposits has given scientists a new perspective on Earth's history and its potential for life, but this was not the only discovery that surprised scientists. Curiosity has found many methane explosions on Mars, sparking debate as to their origin. Methane is a simple organic molecule that is produced on Earth mainly by biological processes. Therefore, the presence of methane on Mars could give rise to the possibility that life, like microbial life, could exist on the planet. In one case, Curiosity recorded methane concentrations 3 times higher than previous measurements. The discovery was more significant when the probe on the European Space Agency's Mars Express orbiter confirmed the presence of methane in the Martian atmosphere, confirming previous observations from telescopes. Further, considering that this methane emission is not constant, the puzzle goes deeper. Instead, there will be a temporary, intermittent breakdown. In 2019, for example, Curiosity measured 21 molecules of methane per billion gas particles in one sample, but that number quickly dropped to 1 atom per billion. By comparison, Earth's atmosphere contains about 1,800 methane atoms per billion air particles. The varying levels of methane on Mars indicate that these emissions have an active source, but they are not known to be biological or terrestrial residues. Life on Mars is supported by the early history of the planet. Although Mars is now a cold, barren desert with an atmosphere too thin to hold liquid water, evidence suggests this was not always the case. Billions of years ago, Mars was larger, had higher temperatures and more water. These conditions make the planet unsupportive of life. However, the organisms that survived were microscopic, like bacteria on Earth. One of the best pieces of evidence supporting ancient life on Mars comes from the study of Martian meteorites. In 1996, a team of scientists led by Dr. David S. McKay announced that they had discovered fossilized bacteria in a Martian meteorite named ALH84001. This meteorite, found in Antarctica, contains tiny structures that some scientists call microscopic fossils. However, this claim is met with suspicion, as similar structures can also be created through non-biological methods. Despite the controversy, this discovery increased interest in the search for life on Mars. Another challenge in the search for life on Mars is the risk of soil contamination. When meteorites from Mars land on our planet and are contaminated by microbes from Earth, it is difficult to know whether life forms originated from Mars or Earth. This problem arose during the study of the Nakhla meteorite, which was discovered in Egypt in 1911. Although amino acids, organic molecules necessary for life, were found in this meteorite, it is believed to have been contaminated by Earth. The existence of liquid water is considered essential for life. Although the current Martian environment is too harsh to support liquid water on the surface, there is evidence that a small amount of water can occur under certain conditions. For example, at the poles of the planet, the combination of sunlight and thin air can sometimes create microscopic water. In addition, research into the nature of subglacial salt lakes at the south pole of Mars is ongoing. Data from the Mars Express orbiter suggests that these lakes may still exist, and future missions are expected to investigate this possibility. Ancient Martian seas are another area of interest to scientists. If these oceans were alive, they could cover up to 75% of the Earth's surface. However, the high salinity of these seas raises questions about habitability. On Earth, microbes such as halobacteria thrive in highly saline environments. If life is similar on Mars, they may survive in the salty water of this planet. In recent years, the discovery of erosion craters on Mars has provided more evidence for the existence of liquid water on the planet. Images from the Mars Reconnaissance Orbiter showed that these craters had grown in just 3 years. This suggests that liquid water may flow onto the surface of Mars from time to time, albeit at a very low rate. The combined observations from Curiosity, Mars Express and other missions have painted a complex picture of Mars' past and present. Evidence suggests that Mars was once a hospitable place with an atmosphere, warmth and abundant liquid water. These conditions can support life, even in a microbial form. Although no definitive evidence of life has been found on Mars, the discoveries made so far have greatly increased our understanding of the planet and its ability to support life. The search for life on Mars is not over. As we continue to explore the universe with more advanced technology, perhaps one day we will find answers to some of the most profound questions ever asked. Are we alone in the universe? Is there life on Mars? And if so, does it still exist beneath the surface of the planet or in its ancient salty waters? At this time, Mars is still a mysterious planet, waiting for its secrets to be discovered. Each new discovery brings us closer to understanding this mysterious world, but also raises new questions and challenges. The Red Planet has a lot to tell us, not only about its history, but about life in other parts of the world. Looking to the future, the search for life on Mars is undoubtedly one of the most exciting and important scientific endeavors of our time. So, as we continue to send rovers, orbiters, and one day, maybe even humans, to Mars, we do so in hopes of uncovering the secrets of this nearby planet. The journey is far from over, and future discoveries could revolutionize our understanding of life on Mars and beyond. Finally, the story of Mars is a story of discovery, perseverance, and the human pursuit of knowledge. As we push the boundaries of exploration and deepen our understanding of the red planet, we are reminded that the world is vast, mysterious, and full of wonder. The secrets of Mars are out there waiting to be discovered. And when we are close to new discoveries, we can imagine what surprises await us in the future.